Hi, my name is Vincent, and today I want to take a look at a linear system of equations. So we have solve the following system of equations algebraically. And we're looking at 2x plus 5y equals 4, and we have 3x plus 7y equals 8. So to solve this using the elimination method, we need to think of this concept of least common multiples. Because right now, the goal is to have matching terms between the top and bottom equations. And right now, the 2x and 3x don't match. And also the 5y and 7y don't match. So we're going to multiply the top equation by 3 on both sides. And we're going to multiply the bottom equation by 2 on both sides. So now when we generate our new system of equations, we have 3 times 2x is 6x. And we have 3 times 5y is a positive 15y. And this equals 4 times 3, which is 12. So now when we distribute the 2 in the bottom equation, we have 2 times 3x is 6x, and we have 2 times 7y is a positive 14y. And this is equal to 8 times 2, which is 16. So now we just accomplished what we needed to. We have matching terms. The 6x and the 6x in the top and bottom match. So now we could subtract the bottom equation from the top equation. So we're going to subtract the left-hand side, and we're going to subtract the right-hand side of both of these equations. So now we have 6x minus 6x is going to cancel. And then we have 15y minus 14y is 1y, or we could just write this as y. So we have y equals, and now we subtract the right-hand side of both of these equations, and we have 12 minus 16 is negative 4. And now the reason why we could do this, remember, we just generated 6x plus 14y equals 16. One of the fundamental concepts in algebra is that as long as we do the same thing to both sides of an equation, we do not change the equality between both sides. So subtracting 6x plus 14y from one side and subtracting 16 from the other side doesn't change the equal sign because these two terms are equal. So now we have one part of our solution. We have y equals negative 4. But remember, a solution to a system of equations should be in the form x comma y. So right now, even though we have the y part of the solution, we still need to find the x part of the solution. So using y equals negative 4, we could substitute back into the system to find the corresponding x value. So remember, the original system was 2x plus 5y equals 4, and we also had 3x plus 7y equals 8. Substituting y equals 4, you could pick any one of these equations, they'll give you the same x value. So let's say we start with the top equation. We have 2x plus 5y, but remember, we just found y equal to negative 4. So we're going to replace y with negative 4, and now we can set this all equal to 4. We're using the top equation in this case. So now we have 2x plus 5 times negative 4 is negative 20, and this equals positive 4. So now to solve for x, we add 20 to both sides. And now on the left-hand side, all we're left with is 2x, and we have 4 plus 20 on the right-hand side, so we have 2x equals 24. So to solve for x, we divide both sides by 2, and this gives us x equals 12. So the rest of our solution we have now. Our solution to this system of equations is at the point 12, negative 4. And this tells us where these two lines intersect. So now I would recommend this next step, if this were on a test, substituting the solution you just found into the second equation. So we're testing out x equals 12 and y equals negative 4 into the second equation. So we have 3 times x, but we're replacing x with 12, plus 7 times y, but y we found to be negative 4, and this should equal positive 8. So now we have 3 times 12 is 36, and we have 7 times negative 4 is negative 28. We set this all equal to 8, and now 36 plus negative 28 is in fact going to be 8. So this tells us that this solution of x equals 12, y equals negative 4 is the solution to this system of equations. Okay, well this is going to conclude this video on solving a system of equations by the elimination method. Thank you all for watching, and I hope this video was helpful.